everyone, welcome to the 11th video lecture of Class 8 Science. So here we will be starting our third unit, Light. So in this video lecture we will be dealing with some of the concepts related to light. That is, first we'll be learning the previous things, whatever we have studied regarding light. Then we'll start with the mirrors and types of mirrors, and we will deeply look into the concepts of spherical mirrors. Okay, so we all know that we have studied little bit about light in our previous classes. So we are seeing different things, and even we are seeing the screen and learning everything because of the presence of light over there, right? So what is this light? Light is a form of energy. We all know this. So it is one of the forms of energy. It travels in a straight line. Always remember, light travels in a straight line. It is reflected by the polished surfaces. If there is light coming in a straight line, and if it encounters any polished surfaces, if it falls on any polished surfaces, what happens? It will be reflected back. The light will reflect, right? So this is what it is saying. So it will be reflected by polished surfaces. And we can see things around us only when the light reflected by them reaches our eyes. So everything we are able to see due to the phenomenon of reflection, and some of the complex phenomena are related to this. But for now we should know that because of the reflection of light, we are able to see the things. Okay, whenever the light falls on the object and that light gets reflected from that object, and that reflected light reaches our eye, and therefore we are able to see the objects. So these are the things we have studied in our lower classes, and something regarding mirrors also we have studied. So mirror is an optical device with a polished surface that reflects light falling on it. So we all know that mirror is an optical device. So we know it is polished and it will help in reflecting the light. A typical mirror is a glass sheet coated with aluminium or silver on one of its sides to produce an image. Okay. So how exactly the mirrors are made? It is nothing but a glass sheet, okay, which is transparent. So what we do, one of the surfaces, every glass will have two surfaces, right? So one of the surface is coated with aluminium or silver, any one among them, and what happens, we will polish it. The aluminium or the silver, it is very polishing or the lustrous thing which will be coated on the one of the surface, so that it will be producing an image, right? Whenever you stand in front of the mirror, you can see yourself inside the mirror, right? The thing which is inside the mirror, which you can see, which is exactly like you, is nothing but the image of you, right? That is called as image. You're an object, and the picture formed of you inside the mirror is called as image. Mirrors have a plane or curved surfaces. So in our daily life we use different varieties of mirrors. Among them, some of them will be plane mirrors, like your dressing table mirrors will be usually the plane mirrors, and the curved surface mirrors, some of them will have curved surfaces, like your vehicle's rear view mirror, okay, that will be usually a curved surface mirror. So curved surface mirrors are spherical, cylindrical, parabolic and ellipsoid. Okay, the shape of the mirror determines the type of the image it forms. So, what kind of a surface we have? So, the image formation will depend upon the nature of the reflecting surface. Um, so, in detail, we will learn about this in the future classes. Plane mirrors form the perfect image of an object. That is your dressing table mirror. Whenever you look into any, normal mirror, plane mirror, what happens? You can see yourself as it is, right? So it forms a perfect image of the object. Here, you is an object, and the thing which you are seeing inside the mirror is an image, right? So it forms a perfect image. You can look and say, yeah, this is me. A perfect thing will be formed. Whereas the curved mirror produce images that are either enlarged or diminished. So always remember, plane mirrors will form the perfect image, same size, everything will be absolutely same. But in the case of curved mirrors, what happens? They form either small images or bigger images, that is enlarged or diminished images. Okay. So mirrors are classified mainly into two groups. One is plane mirrors and the second one is curved mirrors. These curved mirrors are furthermore classified into four groups. First one is spherical mirrors, then the cylindrical mirrors, then the parabolic mirror and the ellipsoid mirror. So in this lesson we will be studying about spherical mirrors and parabolic mirrors. So first we'll be starting with the spherical mirrors. Spherical mirrors are one form of curved mirrors, right? It is one of the type of curved mirrors. If the curved mirror is a part of a sphere, then it is called a spherical mirror. So you take a sphere like your ball. Okay, so if you cut a piece of it, a side piece of it, you can see in the picture the dotted lines are cut from the sphere, okay, taken off from the sphere. The remaining part here, which you can see, this thing and this thing are the representations of the mirror, how exactly they look. Okay, so if they are taken from, if they are a part of a sphere, then they will be called as spherical mirrors. It resembles the shape of a piece cut out from a spherical surface. Okay. One side of this mirror is silvered and the reflection of light occurs at the other side. See, the inside part, the AB, this one, if you see, the inside part is the shaded part or the coated. This inside part is coated with silver or aluminium. Okay, in this case, here this is coated. Okay, so one side, either inside or outside, any one of two sides will be coated with silver or aluminium. So the one side is coated, on the other side the reflection phenomena will take place. Depending upon the nature of reflecting surface, the spherical mirrors can be classified into concave and convex mirrors. Here itself you can see there are two types, right? One second. Yeah. Okay, there are two types. One is shaded or coated inside, another one is coated outside, right? Okay. So when you coat the inside part, the outside surface will be reflecting surface. If you coat the outside part, the inside part will be, or the inside side will be the reflecting surface. So depending upon that, whether the outside is a reflecting surface or inside is a reflecting surface, the mirrors are classified into convex and concave mirrors. Okay. Okay, in detail we will study this. So here is an example of concave mirror. Usually whenever we draw mirrors, remember this, we will represent a mirror, a curved thing, and we will name it MN or AB or PQ, whatever it is. The reflecting surface, you will not write anything. The other side will be showcased like this. These lines represent that side of the mirror is coated. The other side where there is no lines says that it's a reflecting surface. Okay, so this is how we draw the mirror. Okay, moving on. So here you can see this is an example or the diagram of concave mirror. Okay, so what is this concave mirror? Why it is called as concave mirror? Okay, a spherical mirror in which the reflection of light occurs at its concave surface. Then it is called concave mirror. So what is this concave surface means? The concave surface means the bulged in case. If the reflecting surface is bulged in, if it is going in, if this is the reflecting, okay, this is a mirror, there are two sides, one side and the second side. So here you can see the side one where it has gone inside, right? It has bulged inside. If you see the second one, this surface here is a bulged out, right? So if the reflection is happening on the first side, then the second side will be coated, which is opaque. Then that mirror is called as concave mirror. Okay, if the reflection is happening on the concave side or the concave surface means bulged in, the surface which is gone inside. If the reflection is happening in that surface, then it is called as concave mirror. Okay, these mirrors magnify the objects placed once close to them. So what is the property of this mirror? It always magnifies, it always helps in magnifying, enlarging. If the small object is kept, it makes the image bigger, magnifying. Okay, object placed close to it, if any object is kept close to it, what it does, it magnifies it, it enlarges it. Okay, the most common example of a concave mirror is your makeup mirror, which is very small, where you will get it in a makeup kit, right? It will be round in shape and you can see it clear. I mean, it will be very small and it will help in enlarging the things, right? So it's commonly used in makeup kits. So makeup mirrors are nothing but the concave mirrors. So it enlarges the things which are kept close to it. The other type of mirror is convex mirror. So if the reflecting surface has gone inside, then we call it as concave mirror. If the reflecting surface has come out, in this case which is given, the blue color is nothing but the reflecting surface. The if like this, okay, the drawing is very bad, but yeah. So if the surface, the reflecting surface is bulged out, then we call such a mirror as convex mirror. A spherical mirror in which the reflection of light occurs at its convex surface, it is called as convex mirror, whereas convex surface means the bulged out surface. The image formed by these mirrors are smaller than the object. So the concave mirror will enlarge the object, whereas convex mirror will diminish the objects. The most common convex mirrors are rear viewing mirrors used in vehicles. So every vehicles will have mirrors, right? Those mirrors are nothing but the convex mirrors. So why the convex mirrors are used in vehicles as rear view mirrors? Because you can um, so it will diminish, the first property is it will diminish the objects, right? So it helps in seeing the more objects in a small space. So convex mirrors used in vehicles as view mirrors are labeled with the safety warnings. You can just go through it or go and check it. Objects in the mirror are closer than they appear. It will be written on the rear viewing mirrors in your vehicles to warn the drivers. This is because inside the mirrors, vehicles will appear to be coming at a long distance. If you have observed it, whenever you're traveling in any vehicles, if you see the rear viewing mirror, the vehicles which are behind you will appear as if they are coming at a long distance. Okay, so that's why the driver should not get confused. So the caution will be written as objects in the mirror are closer than they appear. So it will it will look as it is very far, but actually it will be very near as compared to the image formed there. Okay. So the mirror used there is a convex mirror. The makeup kit mirror is your concave mirror. Okay, so before going into the image formations, we should really know about the some terminologies, different terminologies which will be used in terms of spherical mirrors. So first we will study this, then after that we will be going with the image formation, how exactly the images will be formed in case of convex and concave mirrors. Okay, the first thing is the center of curvature. So when we started the discussion of spherical mirrors, we said that these spherical mirrors are nothing but the part of a sphere. They are taken out from a sphere, right? I give an example that if you have a ball, if you cut a part of it, not half, if you make a small part, if you take out a small part, the thing which you get is nothing but a spherical mirror. That means it is a part of a sphere. So it is the center. Here the center of curvature is nothing but the center of the sphere from which the mirror is made. I said it is taken out from a sphere, and that sphere will obviously have a center, and that center will be called as center of curvature. Okay, so usually it is denoted by capital letter C in the ray diagrams. Okay, here you can see the C is written here, the C here. So this is the center of curvature for the concave mirror, and here, so you can see the concave mirror will have the center of curvature on the side of a reflecting surface, right? So this is the reflecting surface, right? This side it is, and the center of curvature is also on the side of reflecting surface. But if you see in the case of convex mirror, here, so the sphere, if you form, it will be this side, right? So the center of the sphere will be always to, I mean, the sphere which I have drawn is wrong. Yeah, the center will come in this side. So in this case, the center of curvature and the reflecting surface, here this is the reflecting surface and center of curvature is here on the other side. So the reflecting surface will be not same as the side of center of curvature. So in the case of concave mirror, the center of curvature will be in the side of reflecting surface. In the case of convex mirror, the center of curvature will be on the other side of the reflecting surface. Okay. Pole. It is the geometric center of the spherical mirror. It will be always denoted as capital letter P. So this mirror which is taken out from a sphere will have a center too, and that center will be called as pole. So there are two centers. One is the pole, which is the center of the geometric center of the spherical mirror. Another one is center of curvature. That center of curvature is the center of the sphere from where this mirror has been taken. Then radius of curvature. It is the distance between center of the sphere and the vertex. Okay. So in this diagram, usually in the diagrams it will be represented by capital R. Then the principal axis. The line joining pole of the mirror and its center of curvature is called as principal axis. So if you draw a line, a straight line passing through, not actually joining, it is passing through. If line is passing through both pole and center of curvature, then it is called as principal axis. You can see there are many lines coming to, this is one line, this is one line, this is one line. So there are several lines are given in the picture, but if you can see, there is only one line which is passing through C as well as P. So that is nothing but the principal axis. So that line is the principal axis. That's what. Yeah. Sorry. Here also you can see you are given with C and P, and this is the line which is passing through both C and P, and it is called as principal axis. Okay. Then the next point is focus. When a beam of light is incident on a spherical mirror, the reflected rays converge in the case of concave mirror, or appear to diverge in the case of convex mirror at a point on a principal axis. So not just beam of light, the parallel. If parallel rays, see, you can see there are many lines, as I said. So in this case you can see many lines coming into picture, 1, 2, 3. So all of them are parallel things, right? Parallel rays. So you can see these are the parallel rays. This represents the direction of light falling. So parallel beams are coming. When they fall on the concave mirror, what happens after reflecting, you will observe that they all will meet at one point. It goes like this and comes. It goes and comes, and it goes and comes, and it goes and comes, and it goes. And they appear, and you will see that they all will meet at one point, and that point is called as focus. Even you can see in the case of convex mirror. So convex mirror will always diverge the light rays coming. So these are the parallel rays coming and striking the mirror, and after striking, what happens? It's a diverging mirror. The lights will diverge back. Okay, so if project it backwards, what happens? You can see that these all reflected rays will meet at a point inside the mirror. Inside the mirror, they will meet at a point, and that point is called as focus in the case of convex mirror. Okay. So this is called as focus or principal focus, and it is also known as focus point. Okay, it is always represented by capital letter F. Okay, then the last terminology, the distance between the pole and the principal focus, pole P principal focus capital F is called as focal length of the spherical mirror. Okay, so the distance between, here it is given as V, it should be P. Okay, so the distance between P and F, principal focus and the pole, is called as focal length. So there is a relation between focal length of this spherical mirror and its radius of curvature. The total focal length is half of the radius of curvature. So if you can see in the diagram, principal focus will be always in the middle of the radius. So that is why focal length is given as radius of curvature divided by 2. So this is about the different terminologies related to spherical mirrors. The first one is center of curvature, then pole, then radius of curvature, then we had principal focus, then focus and focal length. The 6 terminologies and their definitions along with the diagram is very much important for the further study. So go through this. This chapter is a bit interesting chapter, so we'll go slowly, and it needs lot of drawings because this chapter contains lots and lots of ray diagrams. So please refer to your textbook for proper understanding. Thank you.